Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and today we are going to study about average. And this will be your lecture number 3 on average. So today we are going to mainly focus on exercises. So let us start with the question number 1. The average of 35 consecutive natural number is n. Dropping the first 10 numbers and including the next 10 numbers, the average is changed to m. If the value of m square minus n square is 600, then average of 3m and 5n is. So we have four options here and we have to see which of them is correct. So let us first recall the concepts that will be useful while solving this problem. So first of all, average equal to first term plus last term upon 2. Average equal to sum of observations upon number of observations. So let's start the solution. Let the first 35 consecutive natural numbers be 1, 2, 3 and goes to 35. So the average n equal to 1 plus 35 upon 2 equal to 18. Now we remove first 10 numbers and including the next 10 numbers 11, 12 and 45. So this is our new sequence. So the average m will be equal to 11 plus 45 upon 2 equal to 28 equal to 18 plus 10, which is equal to n plus 10. So it is actually m equal to n plus 10. So which can also be written as m minus n equal to 10. So this is the equation number 1. So according to the question, m square minus n square equal to 600. So it can also be written as m plus n times m minus n equal to 600. So since the value of m minus n is already known, which we computed in the previous slide, so m plus n will be equal to 600 upon 10, equal to 60. So now adding 1 and 2, we get m equal to 35 and n equal to 25. So average 3m plus 5n upon 2 will be equal to 3 times 35 plus 5 times 25 upon 2. So that will be 115. So the correct answer will be 115. Moving on to problem number 2. The sum of 17 consecutive numbers is 289. The sum of another 10 consecutive numbers whose first term is 5 more than the average of first set of consecutive numbers is. So the average is given by sum of observation upon number of terms, and second formula for average is first term plus last term upon 2, and sum is equal to average times number of terms. So let's start with the solution. Average equal to 289 upon 17, so which is 17. So according to the question, first term is 5 more than the average and 10 consecutive numbers are 22, 23, 24 and 31 till 31. So the average will be first term plus the last term upon 2. So that will be 26.5. So the sum will be equal to 26.5 into 10 equal to 265. So the correct answer is 265. So moving ahead to problem number 3. The average of n numbers is a. First number is increased by 2, second one is increased by 4, the third one is increased by 8 and so on. The average of new number is. So some change is happening here in the numbers, and what will be the average of new numbers? So let us see. First of all, let me remind you some formulas that will be useful while solving this question. First of all, the sum of geometric series, which is equal to a times r to the power n minus 1 upon a minus 1. And another one is average equal to sum of observation upon number of observations. Okay, so let us begin with the solution. So we have a plus 2, a plus 4, a plus 8, dot 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 up to n terms. So the sum is equal to n times a plus 2 plus 4 plus 8 up to n terms. So it can be written as sum equal to n times a plus 2 to the power 1 plus 2 to the power 2 plus 2 cube plus dot 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 till 2 to the power n. And this is nothing but a GP. So using the formula for sum of GP, we will have sum equal to Na plus 2 times 2 to the power n minus 1 upon 2 minus 1. And on simplification, we will have Na plus 2 times of 2 to the power n minus 1, and therefore the new average will be a plus 2 into 2 to the power n minus 1 upon n. The average of 27 numbers is 0. Out of them, how many may be greater than 0? At most, at the most. So we have 27 numbers and their average is given to be 0. So out of them, how many may be greater than 0? So the concept that will be used in this problem is if the average of n numbers is 0, then at most n minus 1 numbers can be positive or negative. 26 numbers may be greater than 0 and 27th will be negative. So that the sum will be 0 to keep average 0. So, moving to problem number 5. The average of 1088 real numbers is 0. So, it is given that the average of 1088 real numbers is 0. So, at most, how many of them can be negative? So, we are interested in finding how many of them can be negative. So, if the average of n numbers is 0, then n minus 1 numbers can be positive or negative. So let us start with the solution. 1087 numbers can be taken negative. So the correct option will be C. So it was directly based on this concept, so we don't have to do lot of computation here. So it directly arrived at the solution. The mean of 15 different natural number is 13. So the mean of 15 natural number is given to us, and the maximum value of the second largest of these number is. So here the sum is the concept that will be used will be sum equal to average into number of terms, and second formula that will be useful is sum of first n natural numbers, that is n times n plus 1 upon 2. So the sum is equal to 15 times 13 equal to 195. So let us consider the 13 numbers 1, 2, 3, 4, 5, 6 until 13. So the sum of these 30 numbers is 91. So remaining two numbers equal to 195 minus 91. So which is equal to 104, and it can also be written as 51 plus 53. So where 53 is the largest number and 51 is the second largest number. So the 51 is the correct answer. If the arithmetic mean of 3a and 4b is greater than 50 and a is twice b, then the smallest possible integer value of a is. So arithmetic mean of a and b is given by a plus b by 2. So this is the concept that will be used here. So the arithmetic mean is equal to 3a plus 4b upon 2, and which is greater than 50. So 3a plus 4b greater than 100, and therefore a is equal to 2b. We will have 3a plus 2a greater than 100. So that means 5a is greater than 100 and a greater than 20. Therefore, what do we get? We get a equal to 20. 1. So the correct answer should be answer number C, 21. Question number 8. The average of three numbers A, B, and C is 2 more than C. The average of A and B is 48. If D is 10 less than C, then the average of C and D is. So we are interested in finding the average of C and D. So the concept that will be useful here will be average equal to sum of observation upon number of observation. So we have average equal to A plus B upon 2 equal to 48. So that means A plus B will be equal to 96. Another thing here we have is A plus B plus C upon 3 equal to C plus 2. So A plus B plus C equal to 3C plus 6. And in the previous slide only we calculated the value of A plus B. So it will be 96 plus C equal to 3C plus 6. This implies that C equal to 45 and D will be 35. So the average of C and D is equal to 45 plus 35 upon 2 and it is equal to 40. So the correct answer will be 40. The average monthly income in rupees of certain agricultural worker is S and that of other worker is T. The number of agricultural workers is 11 times that of the other workers. Then the average monthly income of all the workers is. So in this question, we are interested in finding the average monthly income of all the workers. So this is kind of a story-like question. So we have to just first of all understand the stuff very clearly, then only we will be able to apply the correct approach. So the concept that will be useful here is if we have n1 observations and it has average a1 for n2 observation, the average is a2, then overall average is equal to n1 a1 plus n2 a2 upon n1 plus n2. So moving to the solution part, so it is given that average monthly income of agricultural worker is S. The average monthly income of other workers is T. So agricultural workers is 11 times that of other workers. So this all information is already provided to us in the question. So now agricultural workers is equal to 11S, other workers equal to 1 times T. So the average of all is going to be 11S plus T upon 12. So that will be option number B. Moving to question number 10. If A is 1 upon 6 of C, so a relation between A and C is given. B is twice of A and the average of A, B and C is 30. Then the difference between A and C is. So we have to find the difference between A and C. So sum equal to average times number of terms. So this is the key concept that we are going to use in this question. So we have A is to B is to C equal to 1 is to 2 is to 6. So average of A, B and C is 30. So A plus B plus C equal to 90. So 9 unit is equal to 90, 1 unit is equal to 10. So the difference of A and C is 5 units, which is equal to 50. The average of first 4 numbers is 3 times the fifth number. The average of first 4 numbers is 3 times the fifth number. If the average of all 5 number is 85.8, then the fifth number is. So some information is given to us, okay, and we are interested in finding the average of fifth number. So the key concept that will be useful here is the sum equal to average into number of terms. So let us suppose the fifth number be x. Now the average of first 4 numbers is equal to 3x. Sum of first four numbers will be equal to 4 times 3x by using this formula. So that is equal to 12x. Sum of all numbers equal to 13x equal to 5 times 85.8. Okay. So using this, we have x equal to 33. That's exactly what we wanted to compute. So option number B is correct here. So the average of 5 positive numbers is 56. If the first number is 3/4 of the sum of the last four numbers, then the average of last four number is. So the key concept that will be used here is sum equal to average times number of terms. Let the average of last four number equal to x. So we assume the average of last four number is x. So the sum of last four number is 4x. So the first number will be 3x and the sum is equal to 7x equal to 56 into 5. So we get x equal to 40. So the correct answer will be A, that is x equal to 40. When 2 is subtracted from each of the given n numbers, then sum of their numbers so obtained is 102. When 5 is subtracted from each of them, then the sum of numbers so obtained is 12. What is the average of the given n numbers? So we have some numbers, and when 2 is subtracted from each of them, we get sum equal to 102. And 5, when 5 is subtracted from each number, we get sum equal to 12. So what is the average of given numbers? That's what we want to find. If we have sequence of n terms and its sum is S1 and we subtract p to each term of the sequence, then the final sum is equal to S1 minus np. So this is the key concept here and it is very useful. So answer is summation n minus 2n, exactly doing what we wrote in the key concept, equal to 102, and it is equation number 1, and summation n minus 5n equal to 12, which is equation number 2. So this equation data is already provided to us. So we solve this equation. So we get n equal to 30, summation n equal to 162, average equal to summation n upon n, average is equal to 162 upon 30. So it is 5.4. So 5.4 is the correct answer. That is option number A. Of the three numbers, the average of first and second is greater than the average of second and the third by 15. What is the difference between the first and the third of the three numbers? So here we are provided with three numbers. The average of first and second is greater than the average of second and third by 15. So a relation between the average of first and the average of second and third is given to us. So we are interested in finding the difference between the first and the third numbers. So the formula that will be useful here is average equal to sum of observations upon number of observations. So let us suppose the three numbers B, A, B, C. So the average is equal to A plus B upon 2 minus B plus C upon 2, and it is equal to 15. So on simplification, we have A plus B minus C equal to 30, and it is A minus C equal to 30. That's exactly what we want to compute, and answer will be 30. The average of non-zero number, its square and its cube is 127 times the number. The number is, so let the number be x. The square of the number is x square and the cube will be x cube. So we have the average x plus x square plus x cube upon 3 is equal to 127x. So it will be x times of 1 plus x square. We have taken x common and multiply this 3 with 127. So we get x times of 1 plus x square equal to 381x, and x got cancelled. So it is equal to x plus x square equal to 380. So now what we have to do, we have to just solve the equation, this quadratic equation we have here. And on solving this equation, we will get x equal to 19. So the correct answer will be x equal to 19. The average of x, y, and z is 45. X is as much more than average as y is less than average. Find the value of z. So the average of x, y, and z is 45. So therefore, the sum of x plus y plus z is equal to 3 times of 45. So that is equal to 135, and we name it as a equation number 1. Also, it is given that x minus 45 equal to 45 minus y, that is given to us. So x plus y is equal to 90. This is equation number 2, which was obtained from this one. So now on solving equation number 1 and equation number 2, we get x equal to 45. Sorry, z equal to 45. That's the final answer, 45. So moving on to problem number 17. Out of 4 numbers, the average of the first 3 is 26 and that of last 3 is 24.5. If the last number is 19, then the find first number. To simplify the equation, we are subtracting from one another to remove two variables. So that's the key idea here. So let the number be a, b, c, d. So the average ABC is equal to 26, that is equation number 1. Average BCD is equal to 24.5, that is equation number 2. And on subtracting 2 from 1, we get A minus D equal to 1.5 times 3 equal to 4.5. And it is given that D is equal to 19. So the final answer will be A equal to 23.5. So moving ahead to question number 18. A student finds the average of 10-digit numbers. While copying numbers by mistake, he writes one number with its digit interchanged. So if it was like 17, he wrote 71. As a result, his answer is 6.3. Then the correct answer, the difference of digit of the number in which he made mistake is. So for writing a two-digit number, how do we write it? Mn equal to 10 times m plus 1 times n, and it is equal to 10m plus n. So the difference will be equal to, so if it was AB, then he wrote 10A plus, sorry, he wrote 10B plus A. So the difference is equal to 9 times A minus B equal to 6.3 into 10. So it will be A minus B equal to 7. That's what exactly we wanted to find. So option number A is correct here. Question number 19. The weight of 9 members out of 22 are measured consecutively and their average weight is calculated after each member is weighed. If the average weight is increases by 1 kg each time, so how much heavier is the ninth person than the first person? So the key concept here is, if the average weight is increasing by x kgs, after every time when a weight of next person will be 2x kg more than previous person. So let first draw a table, and the first person, second person till ninth person weight is x plus 2, x plus 3, and it goes to x plus 16. So average weight is x plus 1, x plus 2, x plus 3, x plus 4, and so on. Therefore, the difference in weight of first and ninth is 16 kgs. So the correct answer will be 16 kg. That is option number D. A library has an average of 265 visitors on Sundays and 130 visitors on other day. The average number of visitors per day in month of 30 days beginning with with Monday is. So the key concept here is total number of Sundays in the month begins with Monday equal to 4. So the average is equal to N1 A1 plus N2 A2 plus upon N1 N2. So this is the key concept, these two things. So the total days in month is 30, that is given to us. Sundays are 4, other days are 26. So the average is equal to 265 into 4 upon 26 into 130 upon 30. So that comes out to be 148. So the correct answer should be option number B, 148. So thank you very much. And this is all for this lecture, and see you in the next part 4 of average with some more problems. Thank you very much.